So welcome everyone to my webinar. And today we're going to talk about the Stable-Baselines3 integration with weights and biases. And then by the end of the webinar, you'll learn how to use Stable-Baselines3 to conduct reinforcement learning experiments and how to use weights and biases to keep track of the metrics and the videos of the agents playing the game. So here is the agenda for the talk today. We're going to talk about what weights and biases is, and we're going to talk about what Stable-Baselines is, and I'll talk about the recent integration we made. Then we'll go into a live demo with a Colab notebook, and lastly, I'll also showcase how you can use weights and biases UI to do a lot of experiment analysis in a really easy fashion. So before talking about what weights and biases is, what Stable-Baselines3 is, I want to give you a little context of doing research in reinforcement learning. So overall, as a PhD student, at the start of my PhD program, I was really trying to find ways of how I can do reinforcement learning research, and it was very quick before I realized managing RL experiments can be a pain. There's a lot of problems on the reproducibility side. If you don't record your hyperparameters, your commands that was used to produce the experiment, if you don't record the software dependency, then it's very possible that after just a few months, you wouldn't be able to reproduce your experiment anymore. There's also a lot of issue with analysis and visualization. How you set up, how you save the plots and data can be problematic sometimes, and how you view them aggregately. Those are all little problems, but in aggregate, they become somewhat a pain for research. And there's also the reliability concern with doing reinforcement learning research. There are thousands of reinforcement learning implementations out there, but we know that RL algorithms can be quite sensitive to implementation details. So today I'll talk about how weights and biases will help address the reproducibility challenge, the challenge with analysis and visualization, and how Stable-Baselines will address the reliability. So let's talk about weights and biases in a nutshell. So I will actually share a video from my colleague, Charles, because he has done a really great video just to showcase all of the features. So let me go ahead and share the video.
Weights and biases is the developer stack for machine learning practitioners. Use these lightweight, interoperable tools for the entire lifecycle of your machine learning projects. Experiment tracking, hyperparameter optimization, dataset and model versioning, even sharing results. WB is trusted by over 70,000 machine learning practitioners, delivering better medicine, safer self-driving cars, more sustainable farming, technologies that build a better collective future. You can easily capture all the information you need to make your models reproducible. Your future self will thank you. Start with tracking metrics for a single experiment, then compare hundreds of experiments, visualize thousands of predictions, and share the insights you've gained. Take your existing ML code, regardless of what framework you're using, add a lightweight W&B integration, and quickly get live metrics, terminal logs, and system stats streamed to the centralized dashboard. W&B also organizes the results of entire projects. Even if you and your team tried thousands of experiments, you can still painlessly access the results in a single place, from any device at any time, and query and filter results to spot issues and trends. Track your progress towards the optimal model, take notes on your results across experiments, and share findings with collaborators. Capture the valuable research efforts and insights that are often lost over time, or when a team member leaves. Everything is built to empower collaboration. Just imagine what your team could do with a shared tool for dataset versioning, model management, experiment tracking, and hyperparameter sweeps. That's a quick summary of weights and biases, the flexible, lightweight developer stack for machine learning practitioners. Get started now and see live results in just 5 minutes.
Cool. So that's basically a weights and biases in a nutshell. Let me go ahead and share my screen again. And then you can always go to the weights and biases website. I think our marketing team does a great job in listing all of the features, and you can see how you can integrate weights and biases into your code. There's some code samples, So I highly encourage you to check out our website and documentation. And the website is wmb.ai/site. With that said, we'll talk about what Stable Baselines is. Antonin and Anssi will give you an introduction on what Stable Baseline is. Hand it over to you.
So, thank you. So, well, as mentioned, the idea between Stable Baseline is you have many different RL libraries out there, and we focus on mainly providing reliable implementation of RL algorithm, and while still being user-friendly, and we focus on the very specific case, which is model-free single-agent reinforcement learning. And the last thing we focus on, and that makes us, I would say, different from other libraries, is we favor readability over and simplicity over modularity. So we rather have we don't have many modular components. We mostly have implementation that are not self-contained, but almost self-contained. And then so for the user-friendly part, this is how easy it is to use in very few lines of code. This is for creating a soft actor-critic agent on the pendulum task. So you mostly need to define, it's just follow a scikit-learn syntax. You just define your model class and then call learn on it, so to train the agent. And afterward, after saving and loading with this simple API, you can query your agent with the predict method. And this is most of what you need to know about the API for most of the problem. And for the rest, I will leave it to Anssi.
Right, thanks, Antonin. So just to continue on what Antonin was telling, the other highlights of the Stable-Baselines3 library is that we have almost full test coverage. Almost, there's some nitbits that are not tested, but those are like small things. We have a super active community, so we have issues almost daily we can handle, and bug reports, people reporting bugs and so on, and also doing pull requests, so that's very handy. We also like to advertise our documentation, which covers almost everything, and we always update it when there is some bigger questions. And finally, we also have this comprehensive, like we have callbacks you can modify, but we also have tense report logging, but that's going to be touched on by Costa soon. And finally, we have this training framework included. You can use to run your experiments, store your runs, etc., but also to replicate the results. So we have gone to great lengths to ensure that our implementations are correct. And to that end, we have this zoo library you can use to kind of replicate the runs and store the hyperparameters and so on. But all of this, more on that from Costa. So now I think it goes back to Costa now.
Thank you for the excellent introduction on the Stable-Baselines3. I'm always a big fan of the library. I think all of the features are really well tested and well developed. And with that, I am ready to sort of introduce you to tell you more about how weights and biases could address the three challenge address the reproducibility challenge and the analysis challenge, and how Stable Baselines will address the reliability challenge. So continuing on the reproducibility challenge, so there's a lot of open source reinforcement learning papers or libraries that when I see their instructions for building the library or reproducing a paper, I see instructions like this. It's like sudo pip install gem, and basically they don't really pin dependencies, and sometimes that's pretty problematic, because if TensorFlow, if they modify an API or something, then your code will break. It also sometimes is confusing as to how people are recording their hyperparameters. I've seen some repository where they put hyperparameters as the name of the folders. All of these, and saving the data in CSV files. All of these methods are fairly homebrew. That definitely works, but what we at Weights and Biases is trying to do is to make this whole process much more streamlined so that you can log everything. You can log the software dependencies, hyperparameters, commands to help you reproduce your experiments a little easier. So that's what we're trying to do to say goodbye to this. Instead, we have for each run that you run with your scripts, we record your experiments in a centralized dashboard that you can see all of the information that are related. So for example, we record the hyperparameters and you can see all of the configuration for a particular algorithm. We also log the reproduce commands. In particular, you can see this was a command that in the past I have used to run a reinforcement learning experiment. So usually how I would reproduce this experiment is simply say, I want to clone this repository, check out this, and just copy and paste this command, and I would be able to reproduce this experiment. And we also automatically ping the software dependencies as well. So over here, as you can see, we log the requirements.txt. And another challenge is analysis and visualization. This is something that I personally have felt a lot of pain in. So whenever I go see a reinforcement learning paper, I always see some episodic return curves that look like this. They're really pretty. All the curves are smooth. But when I try to replicate similar plots, I realize it's actually quite a bit of trouble. I usually end up writing 50 to 100 lines of matplotlib code and spend hours to debug it. It was overall just not a very smooth experience, and you have to spend a lot of time and effort into it. Whereas, and also there's to help debug your experiments, in a lot of situations, you also really want to see how well your agent is actually learning. So this episodic return is a great way to understand how good your agent is performing, but it's just a metric. It's not the ultimate measure. To me, the ultimate measure is to visualize what the agent is doing, to actually let the agent play the game or perform the task. Over here, you see a video of this agent playing Hachita. And this agent is actually trained with PPO. And this kind of explains why PPO in this episodic return graph is having less than 2,000 return. It's just because it was stuck in this suboptimal behavior. So if by chance that PPO was exploring the other ways to walk, maybe we can see PPO match the performance of TD3. So recording everything as much as we can is very important. And we also would really like a way to analyze things very easily without writing a lot of code, worrying about how my data is going to be viewed. And also, when we share our results or write experiments note, in the past, I tried to use Google Docs to write experiments notes, and that wasn't exactly, sometimes that was a little bit of trouble, just because if I see a number over at this Google Doc, I don't know where, if it's after 3 months, I wouldn't know where this number comes from. And those are all the things that in Weights and Biases we try to address. So instead of this, in Weights and Biases, you can basically take the data and just generate those plots on the fly. And that's the advantage of having a UI. In a sense, we have these panels that basically work as an interactive matplotlib utility that you can just plot these algorithms. And over here, I also log the videos as well. So overall, it's just really helpful. And the reason why we're able to create these charts on the fly is because I can simply I conduct a lot of experiments, and I can use the filtering and the group tools to filter to obtain the experiments that I really care about. And group is a very powerful feature, because if you group the experiments by the algorithm, then it's going to create these shaded area that are known as arrow bars. So that is a very common practice in reinforcement learning papers. So with Weights and Biases, it's really easy to do. With matplotlib, you usually end up writing a lot of code for it. And we also have a feature called the Weights and Biases report. That is, you can basically write the things that you can in the Google Doc, you can write in weights and biases report, except all of the numbers in a report, you can directly trace through the original experiment. So that really helps with the reproducibility, because if I see a number, I can trace back to a particular run. And if I see the run, if you recall, I have all those reproducibility information, and then I can reproduce the results. So overall, weights and biases just provide a lot of tools to address the analysis and visualization and reproducibility. And as far as reliability is concerned, our reinforcement learning algorithms is really sometimes very sensitive to implementation details. In fact, there is a number of papers on this topic talking about how implementation details could have an impact on the algorithm's performance. And that's where Stable-Baselines3 really shines, is because all of the code goes through a rigorous review process, and all of the code follows really high quality standards, so that you kind of have a peace of mind that this is, in a sense, the most correct implementation. And now we're ready to talk about the recent integration we made with weights and biases and Stable-Baselines3. In particular, we add in our WMB package, there is this WMB callback that can be used with the Stable-Baselines code. And the way you would set it up is you initialize the weights and biases run, you create a model from Stable-Baseline3, and then you have this little callback that allows you to say, I want to save the gradient of the model every 100 steps. And I can save my model to a particular folder so that after the run has finished, weights and biases will automatically upload the model to the cloud. So those are just some highlights. Oh, right. Also, weights and biases callback is going to record all of the hyperparameters that is associated with the model. So the general theme, again, is to try to record everything, as much things as we can, and in the dashboard, so that we can later query those results very easily. And we also support recording videos of the agents playing the game as well. And the code actually becomes a little bit more verbose, but basically you can use this vectorized video recorder to record videos, and our integration will automatically upload the videos that is produced by the gym environment to the cloud. So now is a demo time. So we're going to open a Colab notebook just to see this from end to end, how you can create how you can do a carpool experiments with stable baselines and having all of the metrics and videos being logged to the cloud. So if you go to wmb.me/SB3, that's where you can play with the notebook. So I'm going to go ahead and do that. And let me zoom in a little bit. So I am going to connect to the notebook. Feel free to open the link and try to follow along. I think this will be a really fun practice. So over here, there are just some preliminary introductions. Eventually, we want to put this notebook as part of the Stable Baselines documentation as well, so that it's just a little easier for the adaptation. And then we're going to set up the environments by installing some dependencies. So I'm just going to click Run Anyway. And something you'll notice is that I'm installing the master branch of WMB. This is because I have since made some improvement over the Stable Baselines integration in our WMB package, but the changes is not live yet, but we're pushing a release either today or tomorrow. So by tomorrow, you should be able to replace this with just WMB. So what this part of the code is setting up is installing WMB, Stable-Baselines3, and set up a virtual display so that we can record the videos and upload to the cloud. The next step is to basically run everything we have. I try to make the code as simple as possible. So after this, there's not much left. So if you just run this cell, that will basically create a weights and biases around with all of the metrics. So this is warming up. And it's going to tell you to log in to weights and biases. So you can click on this URL to copy your API keys. So if you would like to follow along with this Colab notebook, please register accounts. And then you can go to WMB.ai authorize, and you'll be able to copy this API key. And then you can paste it here, and it will log your account in, so that all of your experiments will be tracked into your account. So I'll just hit enter. But after this experiment is finished, oh, actually, while this experiment is running, feel free to continue the process. If you want to follow along, just register an account, paste the API key, and you'll be able to produce this experiment. And over here, this cell creates this run page that I can just click on. And it's going to have some basic stuff. And then as this experiment finishes, we're going to see more stuff. And we're only training the agents for roughly 1 to 2 minutes for 25,000 steps. So this should finish pretty soon. And a couple details on the Stable-Baselines integration. As far as how it was implemented under the hood. Oh, there's some display. So basically what's happening under the hood is a Stable-Baselines3 have TensorBoard integration. So if you toggle this TensorBoard log equals runs, it will automatically save the metrics with your experiments to the runs folder. And in weights and biases, we have this argument called sync TensorBoard equal to true. So it's a really straightforward integration that as soon as you turn on this argument, then all of your metrics is synced to the cloud. So now if we go back, this should finish. Yep, the program has ended successfully. It's just uploading the final metrics to the cloud. And now if we go back here, we refresh the page, we should see everything ready. So the first time you see this dashboard, it's going to have quite a few components, but I encourage you to play around with it. And in particular, the way I like to do it is to move this. Oh, also, sorry, let me zoom it in a little bit. The usual way I like to do it is to click on this dashboard, this section over here, and sort of move it at top. And then I usually move the rollouts related stuff to the top as well. So there is a little bit of a customization, so to speak. And then this global global step is not really that helpful, so I'll also remove it. And then I also move the video over here. So that's, oh, there's also the FPS information that sometimes can be quite handy to help you measure the performance as well. But this is basically it. Over here, you can see the mean episodic return. And over here, you can see the mean episodic length with Stable-Baselines. And over here is the video of the agents playing the game. And the weights and biases dashboard is really handy because you can click on this button and see what the agent was doing at different stages of the training. We see that in almost before any training at all, the card pull will fail almost immediately. Whereas if we move it to the middle, it will stay alive a little bit longer, but then it probably will fail, will fall over. And whereas in the end, it would almost balance the carpal almost perfectly. So for me, having this video panel is just a game changer, because it really allows me to view all of my experiments in a very easy fashion, and I can see exactly what the agent is doing, which is really helpful for debugging purposes. And of course, over here, you can see all of the training losses, all of the metrics. You can also toggle this optional gradient logging that unfortunately is probably not very helpful to reinforcement learning models, but it's just so cool to see. And over here, you can play with a couple buttons over here. You can sort of tune with this global smoothing, and you can also tune the smoothing individually. Another thing is that by default, weights and biases has this x-axis being the step, but using the TensorBoard integration, by default uses a global step as the x-axis. So here is when you actually see the 25K total number of time steps for the training. So this is just a training panel. And over here, you can see the system panels as well. So this is also really handy. It will show you all of the system metrics, such as CPU utilization, memory utilization, and so on. It's handy because sometimes you can see exactly how your memory blows up. So if you're training your agents using DQN with the 1 million samples replay buffer, you'll see your system memory just gradually go up. And then if your memory is limited, it will sort of blow up and throw an error to you. But this chart over here will tell you exactly how it was blowing up. Another really helpful debugging utility. And also this GPU utilization is very helpful as well, because it tells you exactly how well your algorithm is using GPU. And unfortunately, sort of most of the reinforcement learning algorithms today have a lot of components that's running on a CPU part, and you need to do constant transfer between the GPU, transferring data between the CPU and GPU devices. And as a result, the GPU is not really utilized that much. So for example, over here, you can see the GPU utilization is around 8. A GPU, at least in my experience, usually really comes handy when you have experiments that uses convolutional neural networks. That's when you see the GPU utilization really goes up. You can see the GPU temperature and the power usage. All of those things are quite interesting if you want to check them out. We also keep the original TensorBoard files, and we keep the logs, the center output and center error of your algorithm. So if you want to log something using a print statement, you can perfectly do that as well. And over here, we have the files tab that contains a lot of useful information as well. The first is this requirements.txt. By default, the Stable-Baseline, the weights and biases integration will automatically log all of your dependencies. Secondly, we also log this model.zip. We'll also log that if you specify this part of the code. If you say model save path. So if you specify this to a particular folder, at the end of your training, this WMV callback will automatically upload your model to the cloud. So again, really helpful. And then you can also see the videos over here, if you want to download them as well. So I think this might be a good point for a pause to see if there's any questions.
We did have one, which was already answered by Antonin. But I guess it might be relevant to other people too. So Antonin, if you could just read the answered question.
So the question was about, does it work for recording with video with different simulator during training, such as Gazebo and PyBullets? So the answer to that is all of the recording rely on your implementation of the GIM environment, and especially on the render method. So if your random method return an image when called with the RGB array argument, then it will work. Otherwise, you will need to define a camera object in Pipelet, and probably the same for Gazebo.
Perfect, thank you. And then we had another one from Chong. It came in a few minutes ago, and it says, I'm curious if the parameter sweep support object, function, and class instead of string and number.
I'm not sure if I understand the question. If the parameter sweep support, are you talking about if we can log like function and classes in the config section of the run? So the short answer is no. I think you can only record strings. So, by the way, thanks for mentioning that. Over here, we log every metrics related to every parameters that are related to the model class. So over here, you can see the action space. You can see the device it was on, the hyperparameters of the algorithm, such as number of epochs, a number of steps. But I don't believe you can record functions and classes because you would have to pickle them, right? Which you can perfectly do if you if you pickle them and then use wmb.save, it's going to upload those pickle files into the into this run, and then you can maybe have a logic to load them later if you want. Yeah, so I'll circle back to this if you have follow-up questions. So sort of following up on the video recording, for the most part, the answer is yes. If you have the arcade environments, such as the Atari environments, then you can it's automatically going to record the videos for you. Versus if you have PyBullets, again, it's also going to record the videos for you. So before diving into this, so I think we're good with the question and answering. And then the next step for me, I think, is to show you some of the ways you can manage experiments and really do a lot of analysis with the experiments. And in a sense, that's really weights and biases shine, because a lot of I've seen a lot of software, they really record the experiments well. They record all of the hyperparameters, the metrics really well. But when you analyze them, it becomes a little bit inflexible. So I'm going to try to do that, show you that. So let me clear everything. So I'm going to set this, I'm going to clear my workspace. So this is, if you go to your project, this is essentially what you're going to see. You're going to see a lot of runs, but maybe this is not immediately enlightening to you. That's where these filters and groups features really come in handy. So in particular, if I say, I want to group things by the algorithm. Actually, sorry, I want to group things by the environment name. So immediately I see there are 3 environments: the carpal, which is basically what we demoed. There's this ant bullet env, and there's breakouts. And there was these runs that not really going to be helpful for us, but we don't want to see it. So we can use a filter to say, I want my env name to not equal to null, right? So you just kind of eradicate that. And then if we see things on the right, it's going to show me a bunch of videos and rollouts. But these are going to, it's going to combine every games of the data from all 3 games. So what I can do is to toggle this I button so that I can see all of the runs that are specific to breakouts. All right. So over here, I see 4 runs. Sorry, I also need to add a filter to say I'll go not equal to run. This is just to purge the experiments that I'm not really interested in. So if you start a new run like this, you shouldn't have to do it. Yeah, so this really showed me all of the interesting pieces I would like to see. And then I can say, using this slider, I can see that, oh, in the beginning of the game, this is where I zoom in a little bit, the agent isn't performing well. You see 8 sort of Atari games playing on parallel. That's because there are 8 parallel environments that was used to train the agent. And as you can see in the beginning, they don't perform very well, but then you can use the slider again to see how they perform in the end. And I think our agent kind of performs very well. And it might have, in this instance, kind of broke the Atari simulator. I have never seen this before, but I think this is kind of like a waiting screen after talking to Anssi, but super interesting stuff. And similarly, I can see the experiments with the pi bullet environment. And over here, I see a bunch of experiments. But this is actually, so let me remove a few things real quick, just to make seeing things a little easier. And you can definitely make this whole process. So in the dashboard, re-record your settings. So once you do this again, all of the settings will be saved in my case, my personal workspace, so that I don't need to rearrange these dashboard every time. It's just the first time I need to do it. So there are actually 2 algorithms. There are TD3. There are 4 algorithms that I run under the Ant bullet and environments. 2 of them is from PPO, 2 of them is from TD3. And the way I can see it is to say, I want to also group things by algorithm. So if I click on this again, I can see there are 2 runs from TD3 and 2 runs from PPO. And this is where things get very interesting. So if I, again, visualize things using the global step, I can see that both TD3 algorithm and PPO algorithm are trained agents for 1 million time steps. But you see for TD3, which is this green curve, the arrow bar is much larger. And why is that? So if I further group things again, if I say I want to group things by name, then it really gives me a lot of insight. That is because the first TD3 run, which is the green run, performs really well. It achieves about 3,000 episodic return, whereas the second TD3 run, which is this Dandy Cherry, performs much worse. That's why if I group things by name, I see the algorithm's performance in aggregates. I see the arrow bars, and then I know that TD3's performance, at least in this limited settings, its performance is a little bit unstable. And I can, smooth things however I like it. And then you can find the source code for sort of doing this. So eventually I'll make these code into the Stable-Baselines integration, Stable-Baselines documentation, or in the weights and biases documentation. But it's really just simple code, right? I have this code produce these Atari experiments where I basically import PPO, set up the hyperparameters that was specific to the Atari environments, and then call the model.learn using WMB callback. All of a sudden, it gives me the video recording and then the episodic return curves. And similar thing with the pi bulletins. It's really straightforward. So let me post this into the chat real quick in case you want to check it out. So that is basically for the experiment analysis part. Just trying to showcase you some basic tools such as the filtering and the group tools that's really helpful for doing experiment analysis. And of course, this report allows you to add a lot of things to it. So if you want to write some notes about your experiments, you perfectly can. So if I want to add something over here, I would just say this is PyBullet experiments, and then I can add a rich set of medias over here. So it's really flexible to help you edit a lot of stuff. And in the past, for my personal research, I use weights and biases extensively. I almost built my entire, I built my research infrastructure using weights and biases. And so with my research with real-time strategy games, you can see this report that almost looks like a paper, that you can find all of the videos playing all of the videos of the agents playing the game. Overall, just offers a really rich visualization, and I can, play around with it, zoom in a little bit. So this sort of goes back to what I was saying. If I see a number over here, I know how to reproduce it, because if I see that these numbers over here, for example, if I see this purple run is performing really well, then all I need to do is to find the corresponding experiment, right? And then simply open it. And I can see, oh, the command that was used to produce it, the hyperparameters, and then the requirements.txt as well. So all of these are readily available to me. I'm gonna pause another second. Does anyone have any questions? Let me see.
There was another one that Antonin already took in the chat. And the question was, is it possible to have 2 or more cameras per PyBullet and for visualizations, for example, agent's first person view and another camera hovering on top of the scene?
Yeah, that's a good question. I think Antonin has already provided a great answer. So if anything, I'm going to try to support that is if you implement your render function in a way that you sort of concatenate the images of both angles in PyBullet, then essentially what's going to happen is you're going to have videos that look like this, where this image is going to be the first angle of your PyBullet and this is going to be the second angle. So as long as you concatenate those images, you can perfectly do so. Any further questions? Cool. For the most part, this is everything I have. I hope it's useful to you. I hope it will improve your workflow. So I think at this point it's just really chatting. Oh yeah, forgot I have this one more thing. So I was gonna try to demo sort of how you can visualize the parameters. Sort of another use case for the grouping feature. So if I run my experiment with different number of steps, how do I visualize their impact on the performance of the agents? And the answer is really just I group things by the environment name and I group things by the end steps. Then I see under end step number of times end steps 512. Then we're going to see 2 runs. So you probably want to run at minimum 2 runs so that you can see some error bars so that you know your experiments works in general, not just that you got a lucky seed. And we can go into these to check out the source code. And again, it's just pretty straightforward. I just modify this end steps to be 512, and in separate runs, I just modify them to 256, etc. So all of these will be, in my opinion, really helps you to analyze the experiments, and just a really great front end tool to help you extract insights of your experiments very easily. And of course, another thing that I kind of forgot to mention is we log all of the models to the run. So you can either download those models and manually load it to your code if you like, but we also provide APIs for you to basically pull every data you want. So you can use our API to download every data is under the charts. But you can also use the API to automatically locate this model.zip and just load it to your code. So it's really flexible and all of your data is always yours. We just kind of store them. So yeah, that's basically it. Feel free to join our Slack channel. Follow us on Twitter or follow our YouTube channel if you like. And this is basically any questions. I'll keep the slides so that you can see the links. Thank you so much for coming to the webinar, and thank you so much for the kind words. Yeah, so let me see, how much time do we have left? So I think we have a few minutes left, and it's sort of open for questions, of course, but probably we could go for a chat. You know, if anyone has any questions for our guests, you also feel free to post in a chat. Antonin and Anssi are very busy, so this might be a great chance if you have any questions about stable baselines. I personally have one. I was wondering, you know, sort of about roadmap. I know, Antonin, you're working on using DQN with vectorized environments. What are your recent thoughts on it and progress?
Yeah, so the question is about using multiple environments to train our policy algorithm like DQN or soft actor critic. So I've got a minimal working version, I would say, that is already online in a separate branch, and I'm in fact currently using it for a European project. So it works quite well and allowed to collect more data much faster, but it needs some tuning compared to classic hyperparameters. That's mostly the main issue, and the other issue is that you will also lose some sample efficiency. You will explore more, you will collect a sample faster, but you will also lose some sample efficiency. And currently the version is only tested for the use case I'm doing, so mostly soft actor critic and TQC, which is truncated quantity critics in the contrib folder, contrib repo. So, and I know also, for instance, it doesn't work with our recent feature, which is supporting any type of observation, especially the dictionary observation. This doesn't work yet, but I plan to work on making that feature proper in September, because before I will be on holidays and I won't have any time for that. So that's mostly it. So it's a nice feature. It works well, but it needs some polishing and it needs some tuning.
Yeah, I love to see eventually DKN works with a vectorized environment, just because PPO works with a vectorized environment and its throughput, and it has it's relatively fast, and it's still easy to debug because your code is mostly synchronous. Whereas I think in the DQN world, you have Apex DQN that, although runs much faster, I feel the asynchronous structure, you know, it's at least to me, you know, it's harder to grasp.
Yes. Yeah. And the thing is, this was a design choice that I made a while ago, that everything was a vectorized environment, because I had that in fact in mind to allow to have a synchronous environment at the end for any algorithms. But first, we wanted to have the baseline working and ready, and not make things too complicated already.
Yeah, makes sense. Makes sense. Looking forward to it. Sort of on the related notes, have you two seen the recent implementation work from Dominic? It's the reproduction of the DQN work, reproduction of the rainbow DQN. Yeah, I thought it was kind of related and super cool at the same time. So for those of you who haven't seen it, this is a work that I personally felt really excited about. Let me see if I can find it real quick. Yeah, I'll post it in a chat. So this is a work from Dominic, and if you read his paper, he basically was able to train the agents using Rainbow, using a fraction of the original Rainbow's paper's cost, while still maintaining a relatively good performance. So for me, that was really exciting. This is kind of the final result that they had. So you can see that Dominic's implementation only runs for 10 million steps, yet it really performs fairly strongly as well, whereas sort of other repositories usually run for longer, although they also perform really well as well. Yeah, let me post this in the chat as well.
There's another question which is in fact quite interesting to answer. The question is SB3 tightly connected to my research position, or is it for the most part a personal project? So it started when we started the first version. It was quite connected to what I was doing, but then it became a personal project as it was done in another lab. And then for the Stable-Baselines3, I got the chance that my research institute allowed me also to work on that during my work hours. So now it's also connected to my research position because I use it for all the research I'm doing. But at the same time, if I was only working on it during my working hours, I couldn't do everything, or it would still miss sometimes. So I'm also considering it as a personal project and working on it at other times. So it's mostly connected to my research position, but it's also part of a personal project. And for Anssi, I will let him answer.
Yeah, for me it's half and half. So I use it for my research, but lately it has mostly been a personal project. I like to help people around answering questions, so Antonin doesn't have to.
Yeah, my hat's really off. My hat's really off to you two, because I really enjoy using Stable-Baseline, especially some of the utility tools for my personal research. It's like I don't need to maintain them. I just kind of import stable baselines and just use the common tools such as the vectorized environments, the Atari wrappers. It's just been a really a joy to work with.
Yeah, and the check environment is also quite used by people because we had so much issues that at the end we decided to write directly a code to check people's custom environment to avoid answering the same question again and again.
Yeah, the vectorized environments, I don't know, I feel like probably OpenAI should have included in the OpenAI Gym repository a long time ago.
There is an implementation, but I wouldn't rely on it.
Yeah, and it has different APIs as well, so I don't know, sometimes it's tricky. How many PRs do you guys review every day?
So pull requests, not that much. Some what we usually have is sometimes either very small pull requests. We got almost one issue per day at least. like or 50 issue per month, more or less. We got more issues than pull request. And for pull requests, it depends because sometimes we just get a big pull requests that lasts 3 months. And this already take quite some time to ensure the quality. Like the dict observation implementation, it took 3 to 4 months to fully, between the first working version to the completely completed version. Yeah, it took us some time. So it depends, but it's mostly issues.
Gotcha.
Big pull request.
Nice. I guess we can wrap up here. I want to say thanks again to Costa for running the webinar. Thanks to all the great feedback in the chat, and special thanks to our guests today for taking the time to talk about your work. The recording and all the materials will be shared in a follow-up email, so be sure to check your inbox in the coming days, and hope to see you around in the WNB community. Take care, everyone. Bye.